1 says, use a factor tree to determine whether each counting number is prime or composite. So first of all, before you answer any question, you have to identify the keywords. Here, keywords are factor tree, prime, and composite. So first of all, we need to know what a factor tree is, and that I am going to show you as we progress through the different questions. And a prime number and a composite number. So why don't we start off with identifying what each of these things are. Now, a prime number is a number that only has 2 factors. Oops. 2 factors. And they are 1 and itself. And a composite number is a number that has multiple factors. So it has more than 2 factors. Okay? So its only factors are not 1 and itself. It's more than that. Now that we've identified these keywords, so now we're familiar with this terminology, we can go ahead and answer these questions. So the counting number in part A is 11. We need to determine if 11 is a prime or composite number using a factor tree. Okay, so how about we start by writing down what we need to identify. So we need to determine if 11 is a prime or composite number. Okay, now when we're drawing a factor tree basically is, its shape resembles a tree. And in this so-called tree, we basically write down the factors. So our number is 11. We have to determine what numbers multiplied together gives us 11. And those numbers are 1 and 11. So 1 times 11 equals 11. And as seen here, we call this a factor tree. And in a factor tree, you start off with your number, and these lines here are your branches. Okay, they're your branches. And these 2 numbers here at the end are your factors. So these 3 components make up your factor tree. And a factor tree, if I was to summarize what a factor tree was, I would say that a factor tree is a method that can be used for determining the factors of a number. Okay? And since we have used this factor tree to determine the factors of 11, and we identified 2 numbers, 1 and 11. Going back to our definition of prime and composite numbers, we can see that a prime number only has 2 factors, 1 and itself. And here, that is true. The factor 1 is here, and 11 is here. 11 is the original number. Therefore, we can conclude that 11 is a prime number. So the key steps to solving these sort of questions is that number 1, you need to determine what is it that you're finding. Number 2, you have to draw up a factor tree and determine the factors of that number. Number 3, go back to your definition of prime and composite numbers and think about which category does this number fit under. So you have to look at your factors and think about the definition and see which one it falls under. Number 4, make a conclusion. And in this example, this conclusion is therefore 11 is a prime number. Part B, 23. We have to determine if 23 is a prime or composite number. To do that, we need to draw a factor tree. So start off with 23, draw our 2 branches, and then we ask ourselves what 2 numbers multiplied together produces 23. Now the only 2 numbers that comes to my mind are 1 and 23. Now to see if the numbers 1 and 23 can be resolved into other factors, the answer to this question is no. So 1 times 23 equals 23, and these are the only 2 factors. Looking back at our definition of prime numbers, we know that prime number is a number that only has 2 factors, 1 and itself. This is true. Therefore, 23 is a prime number. Part C, the number 44. We need to determine if 44 is a prime or composite number. Draw a factor tree. So 44 is a big number. So 44 is a large number, okay? And to see if it has factors simply more than 1 and itself, let's start off with a small number. Okay, let's start off with the number 2. What times 2 gives us 44? We can do this by dividing both sides by 2. Divide both sides by 2. Therefore, this unknown number is 22. So, 2, this means 2 times 22 gives us 44. And 22. Now we think to ourselves, does 2 have any other factors other than 1 itself? The answer is no. How about 22? Does 22 have any factors other than 1 and itself? It does. 22, the factors of 22 are 2 and 11, okay? Because 2 times 11 gives us 22. So we can draw 2 more branches and write 2 and 11. Now we already know that 2 doesn't have any more factors. How about 11? Does 11 have any other factors other than 1 and itself? No, it does not. It has factors simply more than 1 and itself. Therefore, 44 is a composite number. Part D, 105. We need to determine if 105 is a prime or composite number. Write 105 at the top, draw out 2 branches. So what are the factors? What 2 numbers multiplied together gives us 105? Let's start with a small number. How about 2? 2 multiplied by what gives us 105? If we divide both sides by 2, we get 105 over 2. This is not an integer. Not an integer. So we now know that 2 is not a factor. How about 5? 5 times what gives us 105? Divide both sides by 5, which equals 21. So 5 times 21 gives us 105. Does 5 have any factors other than 1 and itself? It does not. Okay, so let's move on to 21. Does 21 have any factors other than 1 and itself? It does. Its factors are 3 and 7. 3 times 7 gives us 21. Now, does 3 have any factors other than 1 and 3? Doesn't. So that's the lowest number it can possibly be. We cannot split it out into other numbers. How about 7? Same as 3, it doesn't. So, from this factor tree, we can see that 105 has factors more than simply 1 and itself. Therefore, we can conclude that 105 is a composite number. In a factor tree like this one, the one we drew for 105, if you pay attention, you will realize that it's written in terms of prime numbers. These are all prime numbers. Okay? So, if a question asks you to write out a composite number in terms of its prime numbers, you will write it as 5 times 3 times 7 equals 105. Okay, but if a question asks you to write a composite number such as 105 in terms of its factors, what you can do is this. First, you use a factor tree and determine its prime numbers. Okay, determine its factors and hence its prime numbers. But after you do that, you need to go back and think, okay, we know that a composite number has factors 1 and itself, but it also has more factors. So the factors of 105, 1 and 105, but then we also have 5 here. Now 5 times 21 equals 105, so next one will be 5 and 21. But then we also have 7, okay? Now 7 times what gives us 105? We can determine this by thinking, okay, next to 7 we have 3, okay? So 7 times 3 gives us 21, but 21 isn't 105. 21 times what gives us 105? Times 5. So we have to do 5 times 3 equals 15. Now 15 times 7 gives us 105. This is how we can determine the factors of a composite number. So we have to draw up a factor tree, determine the most simplest factor, which is number 1 and itself. And then we look at the prime numbers. We're like, okay, given that this is the prime number, what other number do I need to get this original composite number? Okay. And through determining that for all of the prime numbers, we now have all the factors of that composite number. In this case, we have all factors of 105. These are all the factors of 105. If you enjoyed this video, give it a thumbs up and subscribe to my channel for more informative videos.